Now, coming to the molecular orbital theory only. In the last AV, I was discussing about this molecular orbital theory. Continuing with that only. So, we have seen that molecular orbitals, how it is being formed. Now, before just little bit, what you can say, backward, I'll move it so that I'll just give a quick recap. That I have said you already that after the advent of this, what you can say, wave mechanics completely discarded this particular fact that the atomic orbitals overlapped to give rise to a molecular orbital, because it said that when the two atoms will come closer to each other, the electrons which are present in the outermost shell, when they will come closer to each other, they are going to repel. So how the overlapping of atomic orbitals will take place and give rise to a molecular orbitals? It's not possible. Alright, it is not possible at all. Alright, so then what is being possible? How it is being possible? Alright, so it defined, the molecular orbital was defined in this particular manner. The wave function of an electron in a molecule is called molecular orbital. The wave function is denoted with the letter psi, which was used in Schrodinger wave equation. Now, by the help of the wave function, I am going to tell you that how the atomic orbital overlapped to give rise to a molecular orbital. Alright, I think you understood the fact that the atomic orbital does not overlap, as we have done in the case of the covalent bond, that they share the pair of electrons, and in that way the sharing of electron does not take place. What the molecular orbital says that. This is what the molecular orbital says. Alright, so it is not in that particular manner. Alright, but we have studied, because it raises the fact, it justifies the fact that yes, it is not possible when the two atoms will approach each other, the electrons which is present in the outermost shell, they are going to repel one another. Then how the atomic orbital will overlap? Alright, how the overlapping of the atomic orbitals is going to take place. And moreover, according to Heisenberg's uncertainty principle, we know that the position and momentum cannot be defined simultaneously. So when we are defining, when we are saying that the electrons, they come closer together, alright, and they overlap to give rise to a molecular orbital, that means we are defining. Alright, that means we are considering that the electrons are confined between the atomic orbitals. So we are going against the Heisenberg's principle, which is not possible, isn't it? So for all these reasons, it was the valence bond theory, the concept which was given, that was being discarded. Then what we should go for? Now today I will tell you, that is the linear combination of atomic orbital, LCAO method. Alright, LCAO method. By this method I will tell you how the atomic orbitals combines to give rise to a molecular orbital. Before that only I have said you that the electrons in a electron, that is at molecular orbital, is defined as a wave function of an electron in a molecule, we can say that. So wave function is nothing but denoted letter psi. Let us say two elements are there, two atoms are there. One is A, another is your atom B. Alright. Now, how do we have the wave function? Let us say this is your psi A. Look here, that is properly. This is your psi A. Now, this is a wave function of the psi A. Let us say this is a wave function of the psi A. Alright. Now, here this plus minus. Now, plus minus has nothing to do with the charges here. Don't think this is positive and this is negative. No. Just to differentiate between the crest and the trough. Crest is positive, trough is negative. I have written plus and minus. It has nothing to do with the charges here. Alright. Now, let us say this is your psi B. Now, this is your psi A, and let us say this is your psi B. Another, what you can say, wave function. Another atom when they come closer to each other. Understood? Clear? Or we can say that is nothing but another electron. You can also say this is the wave function of a particular atom with particular electron. This is a wave function of another atom of a particular electron, or it can be the same atom and a different electron, we can say that. Clear? So its wave function is this. Let us say this is the wave function of another atom or another electron, rather I should say. So this is plus minus, sorry, it is minus and this is plus. So now if the two waves are in the same phase, you can see this also start from crest and this also start from crest. Listen carefully. When the two waves, they are in the same phase. So when they come closer to each other, then constructive interference takes place. constructive interference. In other words, I should say, it gives rise to a bonding molecular orbital. Because what you find is that the electron density increases. When the electron density is going to increase, energy is released. Alright, here as the two waves are in the same phase, phase means both starts from crest or both can start from trough. So when the two waves are in the same phase, see this is also crest, this is also crest. I can take both the waves start from trough. Suppose instead of starting from crest, it starts from trough. If both are starting from trough, we can say that they are said to be in the same phase. But suppose if one is starting from crest, another is starting from trough. For that reason I have given plus and minus sign. If one is starting from plus, another is starting from minus, then they are said to be out of phase. So when the two waves out of phase, they meet one another, they give rise to destructive interference. Means the electron density is less in that particular case and energy is concentrated. It is not released, energy is concentrated. What I said, electron density is less and as a result energy gets concentrated, means it is more, and due to which the stability is less. But here in case of constructive interference, when the two waves are in the same phase and the constructive interference takes place, then what happens? The electron density increases. Alright, electron density increases, and electron density, when it is going to increase, energy is released. Because formation of new bond is taking place, energy is released. Psi A and psi B. Alright, energy is released, we can say that, and stability is more, because if less is the energy, more is the stability. Less is the energy means the compound which is being formed, the molecule which is being formed, the new bond which is being formed, whatever you say. So there, the energy is less, because what I said, energy is released, so the energy will be less, and hence stability is more. Always energy is inversely proportional to stability. So hence what you see is that, so when the two waves, they come closer to each other, the waves can come, no problem. Electrons cannot come, no problem. Because electrons, they are of same charges, so they cannot come closer, they will repel. But waves, it is waves, they are not of the same charges, we can say that. Here the charge which I have given, I have said you, just to differentiate between crest and trough, mind it has got no charges here. It has got no charges here. Just to differentiate between crest and trough, I have given the positive and negative charge, I have told you earlier only. So two kinds of molecular orbital is formed. One is bonding, another is anti-bonding. Already I have discussed with you. Where bonding is having more more stability than anti-bonding, because bonding is having less energy than the anti-bonding. Anti-bonding is always having higher energy and bonding is having always lesser energy. Now also I said you how it is lesser energy, we can say that. So in case of bonding orbital, nodes are not present. You know what is nodes? Where the electron density is 0, we can say that. Nodes are not present. Rather I said the electron density is maximum here. But in case of anti-bonding, nodes are present, we can say that. Because here the electron density decreases in case of anti-bonding, because the two waves are in out of phase. I'll tell you, I'll show you how the two waves are out of phases. Alright, now it is being formed between by the two two lobes, that is combining lobes have the same sign. See, it is same sign. Also that also you can say that when the two combining lobes have got the same sign. For that reason I said that it may start from crest or it may start from trough, we can say that. Now, like atomic orbital, you are designating as SPDF, but molecular orbital will designate as sigma. This sign sigma pi delta in this way will designate as sigma pi delta. But atomic orbital we have designated as SPDF. We have seen it already, the atomic orbital, isn't it? So here the molecular orbital, bonding molecular orbital will be designated as sigma pi delta in this way. And the anti-bonding will be sigma star, pi star, delta star in this way. This is for anti-bonding. This is a designation for anti-bonding. And this is the designation for bonding molecular orbital. This is for bonding molecular orbital. This is for anti-bonding molecular orbital. Got it? Got it? Clear? So when the two waves are in the same phase, got it? It undergoes constructive interference. Got it? Constructive interference, the two waves. I am drawing the diagram, I'll show you. Just let me explain the theory part. Constructive interference, where the electron density is increased and the energy is released, and it gives rise to bonding molecular orbital. But when the two waves are in different phase, suppose one starts from plus, another starts from minus, there is crest and trough. The destructive interference, where the electron density is less and the energy is concentrated and stability is less, we can say that. And that gives rise to anti-bonding molecular orbital, and it is designated as sigma star, pi star, delta star in this way, we can say that. Clear? Now Next is how we will explain this particular one. Now see here. Look here. So when psi A plus psi B, here I said constructive interference, it is being added. So it gives rise to what? Psi MO. MO means bonding molecular orbital. Got it? You can write BMO also, or you can write MO also, whatever it is. Psi MO. Now how will you represent it diagrammatically? How will you represent it? See here. I am drawing the diagram here and I will show you. Here let me rub it this one so that I will get the space to draw the diagram. Yeah. So this is your nothing but psi MO. I am drawing the diagram for the psi MO. Got it? Where psi MO is nothing but psi A plus psi B, so to say. Now as electron density is increased, so what you find is that what I said, energy is released. So the amplitude is being increased. Amplitude is this plus this now. Alright, psi MO will be psi A plus psi B. So psi A is this much, psi B is this much. The amplitude I am talking to you. Amplitude. So this is amplitude this and this. It's added. And how much we get? We get this. Let us say approximately. I am not measuring it, I am doing it. Approximately I am saying. So this is for psi MO. Where you can see the amplitude is increased. So as the amplitude is increased means energy is distributed. Energy is released. And stability is increased. Alright, so this is for psi MO, the diagram for the psi MO, that is bonding molecular orbital, where this amplitude is nothing but sum of this plus this, and from here only you can understand it, that the energy is released, we can say, because energy is distributed, energy is released. So when the constructive interference takes place, bonding molecular orbital takes place, we can say that, and when destructive interference takes place, anti-bonding molecular orbital takes place, we can say that. Clear? Okay, now you can solve it this one in this particular way also. Like if you square it both the sides, it will be psi A plus psi B whole square. Listen carefully. If you square it, because you know that already in Schrodinger wave equation, psi does not have any physical significance. Psi does not have. Psi square has. What is psi square? Orbital. It is an orbital. What is psi square is? Otherwise, psi does not have any physical significance. We can say that. Okay, so if you say I do the psi square, so psi square means when I square it, this also I have to square it. So it will be psi A plus psi B whole square. It is nothing but A plus B whole square. What is A plus B whole square? Psi square A plus psi square B plus 2 psi A into psi B. Got it? Plus 2 psi A into psi B. We can say that. So energy, what you can say is plus this, we are getting it. Clear? Understood? Otherwise, it is nothing but psi square A plus psi square B. So here it is plus 2 psi A into psi B. But in case of anti-bonding, what it will be? See here. Now I think this one you understood. I am dropping it this one. Okay. Now in case of anti-bonding, what it will be? In anti-bonding, the two waves will not be in the same phase. One will be out of phase, because it is not necessary that both the electrons will start from the same phase only. It is not necessary. Suppose if it is starting, one is starting from crest, another is starting from trough. This is quite possible that another is starting from trough in this way. It is quite possible, we can say that. Now let me make this one is bigger so that it will be easier for me to explain you then. Let me make a little bit bigger. Yeah, this one. So this is plus minus, this is plus, we can say that. Clear? So this is minus plus, we can say that. So it is quite possible. It is not necessary that both the waves always will start from the same phase. It may be out of phase also. So if it is out of phase here, how will you show this one as? Instead of psi, I will write it as psi star MO. Psi star means I have said star means anti-bonding. Without star means bonding. So it will be nothing but psi star A plus psi star B whole square. So will it be plus? No. It will be minus. Just now I said. Because it is destructive interference. Got it? It gives rise to anti-bonding. So it is psi A minus psi B, because amplitude of A is greater than that of B. If suppose B would have been more, then psi B minus psi A. Alright? Why it is psi A minus psi B? Because psi A amplitude and psi B amplitude you see. Psi A amplitude is more and psi B is less. So hence it is psi A minus psi B. Suppose psi B will be more, the amplitude of B will be more. Suppose, let us say, then it will be psi B minus psi A. What you can say, we will be doing it. Clear? I think this part is over. So, what will be the diagram in that particular case? So here it is, the diagram will be this sort of. What is that? Now this the diagram I am doing for what? Anti-bonding. I am doing the diagram for anti-bonding. So I will subtract it, this one. When I will subtract it, this minus this, I will do what I will get. The resultant is this almost, we should say. The resultant is this almost. Now here there should not be any confusion. Sir, this is starting from crest and this is trough. Okay, I am subtracting it. I am subtracting this much part. So this part I am getting it. Alright, again I am subtracting from here this much part and this part I am getting it. That is the way we are doing it. Understood? Because I have said you plus and minus sign has nothing to do with the charges. It is just simply to denote the crest and the trough. That's it. So here should not be any confusion. He said this and this I will subtract. Yes, we can do it. No problem. We can do. For that reason only we are doing, because this is in the crest and this is in the trough. So as they are starting different phase, that reason only we are subtracting. If it is starting from the same phase, then it is positive. In positive interference, we can say that. Constructive interference, bonding molecular orbital, energy is released. Already I said you all these things. So here, so there should not be any confusion that this one positive and this is negative. Whereas for that reason only I am subtracting it. That is the reason I am subtracting it. And hence, the resultant this one and this one is subtracted. The resultant is this, I am getting it. So here what you find is that energy is, what is that? It is not released here. Energy is not distributed here. Energy is concentrated here. See here, the amplitude is decreasing. So energy is concentrated, decreasing. Compared to this, it is decreasing. So energy is concentrated. Alright, energy is not released, due to which it is unstable in nature. Now mathematically, how will you understand it? Same thing, I will do the square of it. I will do the square of it. So now when I do the square, this will be nothing but psi a minus psi b whole square, which will be nothing but psi square a minus b whole square. That is psi square a plus psi square b minus 2 psi a into psi b. A minus b whole square, a plus a square plus b square minus 2ab. So here what you will find, that is minus 2ab you are getting. Minus, that is nothing but 2 into psi a plus psi b. So some amount, what you can say is that is I am taking it out from here. What I am taking it out? That is amplitude that is decreasing here. Some amount. But here in case of the previous one, psi a plus psi b whole square, what is that? I am adding it. Psi square a plus psi square b plus 2 psi a and psi b. I am adding it. For that reason, you have seen the energy was increasing, the amplitude was increasing. Alright, but here what I am doing, psi a minus psi b whole square. What is that? Psi square a, this one, psi square a plus psi square b minus 2 psi a into psi b. So psi a into psi b minus, I am decreasing it. And what you can say, reducing it. What I am reducing it? Energy is reducing. The amplitude is being reduced. So energy is not distributed, rather energy is being concentrated. So mathematically also we can understand in this particular way. So in this way, what we find is that by the method of LCAO, we can explain that how the atomic orbitals combine to give rise to a molecular orbital. That is, atomic orbital does not combine in this manner. Just like you have seen in valence bond theory or in any other approach, Lewis dot diagram or whatever it is. Then how do they combine? They combine in terms of waves. Alright, they combine in terms of waves, they combine. Waves overlap. So if the two waves are in the same phase, if they overlap, that is called as positive overlapping, constructive overlapping. But if they are in different phases, it is negative overlapping or destructive overlapping, we can say that. Clear? We can see. So this gives rise to anti-bonding molecular orbital. In the previous diagram you have seen it, it gives rise to bonding molecular orbital. In this way, that is molecular orbital theory explains that how the atoms combines to give rise to a molecular orbital. Alright. So one more what you can say approach I am showing you, that is the difference between what you can say VBT and MOT. You will be getting it clearly. You will be getting it. A difference between valence bond theory and molecular orbital theory, clearly you will be getting it. Now what is that? Now look here. Look here and see. Suppose we are having, there is a two orbitals, we can say two orbitals. Now according to VBT, valence bond theory, how they overlap? In this way, they overlap. Alright, this is according to VBT. According to MOT, how do they overlap? They do not overlap in this way, rather they distribute their energy in this manner. This is according to MOT. This is according to VBT. It is just like, suppose you are taking a pan, a fry pan, you're taking it. You're taking 2 eggs. Egg, you're taking. You are, what you can say, breaking that egg and you're putting in the fry pan. Got it? So when you're breaking that egg and you're putting in the fry pan, what you'll find is that these two, let us say, are the egg yolk, yellow color, will be separated, will be going far apart from each other. Isn't it? It will be going far apart from each other, the 2 egg yolk. Or you can say that, you can do it in other ways also. That is, you take the 2 eggs and you put it in one glass. Break it in one glass. And then what you do is that you put it in the fry pan. Then what you will see, it will get separated in this way. Alright, in this way it will get distributed. The 2 egg yolks will be far apart from each other. Of course, in that case, egg yolk you will not see because they will mix each other. But if you put it in the fry pan, then it will be easier for you. That is, you take the 2 eggs and you put it in the fry pan, far apart from one another. You will see it will be in this manner. But the 2 egg yolk, you take it and put it closer to each other. Alright, then you will be getting this sort of. The 2 egg yolk will be this, and when you break it closer, then it will be this sort of. Alright, and when you break it far apart, then it will be this sort of, or if you break it in a glass and put it in the fry pan. Just, it's a concept I am saying you to make you understand that valence bond theory and the molecular orbital theory. You may agree or you may not agree with me. It's up to you. Got it? But just it's a concept what I thought of to make you understand about this particular thing. That is, in case of valence bond theory, what you find is that the 2 atoms, they are closer. So for that reason I said 2 eggs. What you do is that you break it closer and you bring it closer. The 2 egg yolk will be closer to each other. Alright, that is according to valence bond theory. But what you can say is a molecular orbital theory is that there is 2 egg. What you do is that you break it far apart, or you break it in a glass and then you put it in the fry pan. So what you will find is that you will find the egg yolk will be far apart from one another. Alright, what is there in that particular case? Energy is distributed. Here the energy is concentrated. So this is not possible, but according to the modern approach, according to the wave mechanics, this is possible. We have got justification for it. We do not have any justification for it. It is absolutely true that when the atoms having the same charges will approach each other, same charges means the electrons which are being present in the outermost shell. In every atom, electrons are present in the outermost shell. So when they will come closer, definitely they are going to repel. Alright. So a lot of things I said you about molecular orbital theory and valence bond theory. I hope you have understood this particular one. And the molecular orbital theory, you have seen it. It's according to the Aufbau's principle, because last in AV I have said you that it will be filled in the increasing order of energy. First bonding, then anti-bonding. Bonding is always having lower energy, anti-bonding is higher energy. Then it is being filled according to the, what you can say, of what is that? That is Hund's rule of maximum multiplicity. That is, first one electron will be from each subshell it will go and it will be filled. So first the lower subshell will be filled, then after that the higher subshell will be filled. Got it? So if there are 2 or more degenerate orbitals will be there. Let us say px, py, pz. So how it will be filled? One will go to px, one electron, another will go to py, another electron, then another will go to pz. According to Hund's rule, we can say that. So it is according to Aufbau's principle, it is according to Hund's rule, it is according to Pauli's exclusion principle. How Pauli? Because a molecular orbital can accommodate how many electrons? 2 electrons. Of what spin? Opposite spin. Not of the same spin, opposite spin. You have seen it. In the last day we have drawn it, the atomic orbitals. And then I have drawn the molecular orbitals. In the molecular orbitals, how many electrons I have kept? Maximum 2. It can be 1, but maximum can be 2. It cannot be 3. Alright, so molecular orbital theory is in accordance with Aufbau's principle, is in accordance with the Pauli's exclusion principle, is in accordance with the, what you can say, the Hund's rule of maximum multiplicity. I have discussed with you, that is the postulates. If you go through the postulates, you will find it out. In the postulates, it is being clearly said that each molecular orbital can accommodate maximum of 2 electrons of opposite spin, we can say that. And the shape of the molecular orbital depends upon the shape of the combining atomic orbital. Definitely. S subshell is spherical, P subshell is dumbbell, so accordingly molecular orbital also will be, that is spherical and dumbbell, we can say that. So the shape of the molecular orbital depends upon the shape of the combining atomic orbital. So it says of the shape also. Shape means it is in accordance with the VSAPR theory also, we can say that. Clear. Next is molecular orbitals are arranged, I have said you already, just I am repeating this one, are arranged in the increasing order of their energies. They are filled in the same way as it is being done in atomic orbitals. In the atomic orbital we are doing 1s, 2s, 2p, 3s. Here also same thing. Here also same thing in case of molecular orbital. What it will be? First bonding, then anti-bonding. So sigma 1 is sigma star 1 is. Sigma 2s, sigma star 2s. Just now I said you know. that molecular orbital can be denoted as sigma, delta, pi, and antibonding is sigma star, pi star, delta star. So hence I am saying you 1s will combine to give you what? Two molecular orbitals, sigma 1s and sigma star 1s. 2s will combine to give you sigma 2s and sigma star 2s. One bonding, antibonding. Bonding will be the lower, antibonding will be higher. Bonding will have lower energy, antibonding will have higher energy. Accordance with the, what you can say, of Bauer's principle, we can say that. Clear? And electron pairing in degenerate molecular orbital cannot take place unless each degenerate molecular orbital singly occupied. Just now I studied. When you are filling in degenerate orbital, degenerate is having the same energy. Which are having the same energy? 2px, 2py, 2pz. Or in case of desorption, 3dxy, 3dyz, 3dxz, 3dx square y square and 3dz square. 5 orbitals are there in case of desorption. So in each molecular orbital, first we will give, for example, there are 3 electrons are there in the 2p sorption. So one electron will go to 2px, another to 2py, another to 2pz. That is, first it will go to bonding and then after that it will go to antibonding. It will be filled in the increasing order of energy. So it is the molecular orbital theory is in accordance with the Hund's rule, is in accordance with Bauer's principle, is in accordance with Pauli's exclusion principle, also it is in accordance with the VSEPR theory, because it also gives the shape of the molecule. Because I said you, the shape of the molecular orbital depends upon the shape of the combining atomic orbitals. And any atomic orbital, last we said, does not combine to give molecular orbital. Like 1s will combine with 1s. 1s cannot go with 2s. 2s with 2s. 2p with 2p. Alright? It cannot be 2p and 3p. No. They are not comparable energies. They are of different energies. We can say that. Clear? So this is about the postulates of the molecular orbital theory, and I said you how the atomic orbitals combines to give rise to molecular orbital and the difference also. Now we are going to come to the MOT diagram. Okay, thank you.